Okay, number one on your review says the function below can be used to describe the path of a bird flying through the air. F of x equals x squared minus 14x plus 48. What is the correct factorization of this function? So for this one to do the factors, you have to figure out what are factors of 48 that if you added them up, they would equal negative 14. And this right here, this is a positive number, but this one is a negative number. So that tells me both of my factors are going to have to be negative in order to add up to a negative number. So I'm looking at negative 6 and negative 8. Let's test it. If I do negative 6 plus negative 8, it should equal negative 14, and it looks like it does. So the way we're going to write our new factors is negative, okay, the way we're going to write our factors is x minus 6 times x minus 8. And these are your factors for that trinomial. Number 2 says a toy rocket is launched from a platform 45 feet above the ground at a speed of 95 feet per second. The height of the rocket in feet is given by the equation f of t equals negative 16t squared plus 95t plus 45, where t is the time in seconds. How high will the rocket be after 2 seconds? So there's a few different ways that you can work this problem. You can substitute the 2 right here in everywhere where you see a t, right here and here, and solve it and get your answer. But I'm going to show you guys how to put it in your calculator and call up your t chart, because we know t or x is going to be equal to 2. So we just need to figure out when x is 2, what is y. So let's go to your calculator, and from the start menu, you're going to go down to your graph, and we're going to type in negative 16. Instead of t, I'm going to do x. It won't work if you put t squared plus 95x plus 45. So it's graphed. Now you're going to hit Control T for your table, and we're looking for where the rocket is at after 2 seconds. And if you see right here, it's 171 feet in the air. So your answer is going to be 171. And if it's griddable, you would just grid 171. Number 3, write a polynomial that represents the volume of the prism using x. Now, anytime you do volume, you are going to multiply length times width times height. So we're given 3 measurements right here, and we have to multiply all 3. So don't get confused and add and subtract. You have to multiply. So I'm going to pause the video for a second. I'm going to set up my equation. Okay, so I've got my equation set up where I'm multiplying all 3 sides, and you see this 3x right here. I'm not going to do that just yet. I'm going to FOIL these 2 equations, and then I'll multiply the 3x after I FOIL. So when I FOIL, I'm going to do first times first, and that's x times 2x, so then I get 2x squared. And then I'm going to do outside times outside, x times 4, and that's a positive 4x. My next step is to do inside times inside, so it's 2 times 2x, which would be 4x. And I apologize, it's a bit sloppy, but that's okay. And then last in this one times last in this one, so it'd be 2 times 4, which is going to be 8. Okay, and I'm going to put it in parentheses. Normally your parentheses will drop away, but we still have to multiply everything by this 3x. But before I do that, I'm going to combine my like terms. So let me clean it up a bit and then we'll combine our like term. Okay, in combining our like terms, 2x squared doesn't combine with anything, so we're just bringing it straight down. We got 2x squared. We have a 4x here and a 4x here. Those are like terms, so we're going to add those up and we'll have 8x. And then we just have this 8 right here that doesn't combine with anything, so we just bring it right on down. Keep your parentheses because we're multiplying everything by 3x. Okay, so let's start by multiplying 3x times 2x squared, and we should get 6x to the third, because 2 times 3 is 6, x squared times x to the 1, you add your exponent and that would be a 3. Now we're going to do 3x times 8x. 3 times 8 is 24. And then we have x times x, so that makes it x squared. And then lastly we have 3x times 8. 3 times 8 is 24. And then there's just the 1x with the 3, so we just bring that down. And here's your answer. Nothing else combined, so we don't have to combine any like terms. So it's 6x to the third plus 24x squared plus 24x. After you multiply all three sides, this is your polynomial that you get for your volume. Number 4 says factor the trinomial 5x squared plus 11x minus 12. And because this does not have a leading coefficient of 1, it's got a leading coefficient of 5, we have to get factors of 5 and factors of negative 12. So I went ahead and I set up our chart to help us get our factors. And 5 is easy because we can do 1 times 5 and that equals 5. 12 we might have to play around a little bit because you could do 1 times 6, you could do 2 times 6, or we could do 3 times 4. I'm going to start out with 3 times 4. And because this is a negative 12, one of these is going to have to be negative. And we'll figure out which one in just a minute. To test it and see if we have the right order and the right factors, you're going to do outside times outside. So it'd be 4 times 1, and that would be 4, plus inside times inside would be 5 times 3, which would be 15. Now I think this might work, but our answer is a positive 11. We need to make this a negative 4, and in order to do that, I'm going to have to make this 4 right here negative. So if we do negative 4 plus 15, we would get a positive 11, and that would work out. So that would be it. These factors right here are the ones that have our x's, and they're the first term in each of our parentheses. So let me go ahead and set up my parentheses. And my 1x is going to go over here, and my 5x is going to go right here. The 3 and the negative 4 are my second term in each parenthesis. So I'm going to write it. Let me change colors. It's going to be 1x and 5x. It's not very pretty, but that's okay. And then 3 is going to go over here with my 1, and it's positive, so we're going to do plus a 3. And my 4 we decided needed to be negative, and it's going to go with the 5x. Whoops. That is a 4. Let me type it a little bit neater. Okay, so I went ahead and I typed your answer so it would look a little bit neat, but after you factored this trinomial right here, this is what you should get. And if you're not sure if that's correct, you can always go back and FOIL this, and if you FOIL it, you come right back to this trinomial. So that's number 4. Number 5, multiply 5x minus 3 times x squared plus 2x plus 4. So this one's a little bit different because we can't exactly FOIL, but I'm going to have to multiply 5 times everything in the other parentheses, and then I'm going to have to multiply 3 times everything in the other parentheses, and we'll do it in different colors so we can kind of see our like terms. Okay, so let's start my multiplying 5x times x squared. When I multiply 5x times x squared, I get 5x to the third. When I multiply 5x times 2x, 5 times 2 is 10, and x times x is going to be x squared. When I multiply 5x times 4, I get 20x. Okay, now let's do our negative 3 times everything. Negative 3 times x squared is going to be negative 3x squared. Negative 3 times 2x is going to be negative 6x. Negative 3 times 4 is going to be negative 12. Now, we have a lot of numbers going on, so we got to see what we can combine. And 5x to the third does not combine with anything, so I'm just going to bring it right down. 5x to the third. And I like to mark them off when I'm done with it. That way I'm not looking at so much. Now I have a 10x squared and a negative 3x squared. So 10 minus 3 is going to be a positive 7x squared. Okay, and I'm going to mark those off because I'm done with those now. And then over here I've got a 20x and a minus 6x. So 20 minus 6 is going to be a positive 14x. And let's mark those off. And it looks like the only thing I'm left with is the minus 12. And it's all in order and everything's combined, so that is your answer. Number 6, determine the range of the function graph below. So your first step is figuring out, well, what is the range? And the range is your y. So you're looking at the y-axis right here. You're trying to see how high or how low the parabola goes. And it looks like it bottoms out at negative 6. So y can be negative 6 and everything bigger. And the way you would write that is y is greater than or equal to negative 6. And that is how you write the range of this parabola. Number 7. What statement best describes the graphs of y equals 10x squared and y equals negative 10x? And if you don't know right off the top of your head what the difference is, go to your calculator and graph it. So you're going to go to the parabola down here, and the first one is 10x squared, and you hit tab, and then you do negative 10x squared. So to me, the widths are exactly the same. The only thing that's different is one of them opens up and one of them opens down. So let me go back and I'm going to type our answer. Okay, so your answers are, or your answer is, one opens downward. The one that is y equals negative 10x squared opens downward because of the negative. And the other one opens upward, the y equals 10x squared, because it's positive. And the widths for both of these graphs stayed the same. And that's your answer for number 7. Number 8 says, how does the graph of f of x equals x squared plus 2 differ from the graph of g of x equals x squared minus 6? And if you don't know right off the top of your head, you need to go to your graph and you need to graph it. So from the home screen, you're going to go to the parabola, and we're going to enter the first one, which is x squared plus 2. To get the other one on the same graph, you hit tab, and we're going to do x squared minus 6. And the x squared minus 6 is the one that's in red, which is our g of x, and the one in blue is our f of x. So it says, how does f of x differ? So f of x is the higher one, and it's shifted upward. So let's see how many units. It's 1, 2, 3, 4, 5, 6, 7, 8. f of x is 8 units higher than g of x. So I'm going to go back to our screen and I'm going to type that. Okay, so I went back and I typed in f of x is shifted 8 units higher than g of x, and the widths are the same. Now on your calculator screen it won't look like the widths are the same, but you can look at the number in front of x squared, and if it's the same, like for instance this is 1 and this is also 1, then the widths are exactly the same. So the only thing that's different is f of x is higher up than g of x, and it's 8 units higher, and that's your answer. Number 9, it says use the following graph to answer both questions 9 and 10. So number 9 says use in the graph at what selling price S will the business maximize their profit. So when I hear maximize, this word right here, whoops, I'm automatically going to think vertex, because maximize is talking about their highest point. And let me see if I can get that written. So we're looking for the highest point, also known as the vertex, and this is the highest point. So it's asking at what selling price. And I noticed the Y is the profit, so we're not looking at the profit. And the X is the selling price, so we're looking at this X value right here. And that's going to be our answer. So when they sell their product for $40, their profit is $10,000, which would make sense. You don't want to sell it for $10,000 and profit only $40. When they sell it at $40, their profit is $10,000. And that is your answer. You would bubble in just the $40 right there. Number 10, we're using the same graph that we did on number 9, and number 10 says using the graph, at which selling price will the profit be 0? So profit is your y-axis, and we're looking at when it's going to be 0. So when the profit's 0, it's going to be crossing this x-axis. So these are the only times right here that this parabola crosses the x-axis. So at $20 and $60, when they sell it for those prices, they don't make any profit. So that's when profit is 0. Number 11 says, given f of x equals x squared minus 1 with a domain of -1, 0, 2, 3, and 5, what is the range R? So I went ahead and I set up my t-chart with the domains that they gave us, which domain is your x. So now we have to figure out the y. And to me, the easiest thing for us to do is go to our graph. We're going to go to our parabola. We're going to hit tab. We're going to type in x squared, whoops, minus 1. There's our parabola. Now we want to pull up our XY chart. So you're going to hit Control T for table. And we're going to look up those domains. So when x is -1, we have a 0. When x is 0, we have -1. When x is 2, we have 3. When x is 3, we have 8. And when x is 5, we have 24. So I'm going to go back to our document over here, and I'm going to plug in those y's. Okay, so here's your completed XY chart, and you guys should write that on your review, and it tells you when x is -1, y is 0, and so on. And that's what it's asking for when it says what is the range. You've got to get all your y values, and to me the easiest thing to do is to graph it and pull up your t-chart. Number 12, a golfer hits a golf ball. The quadratic function f of x equals -8x squared plus 64x gives the height of the ball at x seconds. How long does it take for the golf ball to return to the ground? So I went ahead and I drew a little picture to help me visualize it. Here's the height on your y-axis. Here's the time on your x-axis. Here's the ball, and we know that it's going to go up and then it's going to come back down. So to me, the easiest thing to do would be to go and graph this function right here and to figure out, well, when y is 0, what is our x? And that'll tell us how long it took for it to come back to the ground. So let's go to our graph. We're going to hit our parabola, and the function is negative x, 8x squared plus 64x. And you can't really see the whole thing, but that's okay because we're going to hit Control T, and we're going to pull up our t-chart, and we're going to see at how many seconds it comes back down. And you can kind of see right here, its vertex is 4128 because now it's going to start coming back down. So if we keep going, we see that after 8 seconds, y is 0 again. So our answer is going to be 8 seconds. Okay, and that is your answer for number 12. Number 13 says, write a polynomial to represent the area of the shaded region, then solve for x given that the area of the shaded region is 65 square units. So I'm going to go ahead and set this up, because when you do area, you're going to do length right here times width right here. And then if we only want the shaded region, we're going to have to minus the area of this inside circle, inside rectangle. So the inside rectangle, the area is actually 4x if you do length times width. So first, let's go ahead and get it set up. Okay, so now I'm going to FOIL this right here, my length and my width. I'm going to FOIL it, but you cannot forget to minus that inside rectangle. So when I FOIL, I'm going to do first times first. So it'd be 4x times x, and I get 4x squared. Outside here times outside here. 4x times 4 is going to be a positive 16x. And then we're going to do inside here times inside here. Negative 1 times x is going to be negative 1x. And last here times last here. Negative 1 times negative 4 is negative 4. And everything's FOILed out, but I've got to bring down this minus 4x so that I don't forget about it. If I don't bring it down, I'm going to forget. So I'm going to go ahead and bring it down. Now I'm going to combine my like terms. I have a negative 16x, or a positive 16x, a negative 1x, and a negative 4x, but nothing else can combine. So I've got 4x squared that just comes down. 16 minus 1 would be 15. 15 minus 4 would be 11. So it's going to be plus 11x. And I'm going to go ahead and mark out everything that we've already done or brought down. So that's done, that's done, that's done, and that's done. And all we're left with is that minus 4. And that would be the area of just the shaded rectangle. That's your answer. Number 14, what are the x-intercepts of the graph of the quadratic function f of x equals 3x squared plus x minus 2? Now, we need to see the graph so that we can look and see what the x-intercepts are. So I'm going to go to my calculator, and I'm going to graph it. Hit tab. We've got 3x squared plus x minus 2. Now, to me, it's a little bit hard to see exactly where my x-intercepts are because this one falls exactly on negative 1, 0, but this one is in between 0, 1. So the way that I can tell exactly where my x-intercepts are is menu, analyze graph, and zeros. And it gives me this little range bar. I'm going to click it, and then I'm going to, and then I'm going to scroll past my zeros. So this one is at negative 1, 0. We already know that. And this one gave us a little decimal. But just in case your answer choices are not in a decimal, I'm going to write that down, and then I'm going to go to my calculator, and I'm going to see how that decimal would convert to a fraction. So I'm going to hit calculate, 0.667, enter. Then I'm going to hit menu, number, approximate to fraction. And it gives this long thing, but that's okay. Hit enter. So there's what your fraction would be if it does give it to you in a fraction. Okay, so I graphed it and I analyzed my graph and I found my zeros. And now I'm going to go back to our review and I'm going to type those in. So my first one was -1. Oops. -1, 0. Let me put my little parentheses so that we know that it's a coordinate. And my second one was 0.667 and 0. Another way of putting that would be 667 divided by 1, 1, 2, 3. So either this one or this one could be your zeros. Number 15 says graph points -2, 0 and 4, 0 on the graph. These 2 points are from a quadratic function on the grid. What is the equation of the axis of symmetry of the graph of this function? So the first thing I'm going to do, I'm going to graph the 2 points to help me better figure out where the axis of symmetry is. So the first point is -2, 0, so that'd be right here. And the second point is 4 and 0. So now we got to figure out where would they split, where would the axis of symmetry be that split these 2 points exactly in half. So to me it looks like exactly in half would be at the 1. Whoops, that is way sloppy, because if I go 1, 2, 3, I'm at this point, and then if I go 1, 2, 3, I'm at this point. So the 1 is where we split exactly in half, and the way you write that, the axis of symmetry crosses the x-axis, so you write it as x equals 1. Do not write it as y equals, because it does not cross the y-axis. It crosses the x-axis, so it's x equals 1, and that's your equal.